when I used ChatGPT for the first time, I was curious, how is it possible? How can a chatbot that intelligent? And that led to a journey for me to discover what is the magic behind this. Because some might like to mention that LLM stands for looks like magic, but the biggest question is it? Is it just some one-trick pony or some other secret that is hidden from us by OpenAI? So when I began my journey trying to understand LLM a few months ago, there were very little resources. There are tons of papers, YouTube videos, and so on and so forth. But it seems that you have to have a PhD in machine learning to be able to digest those. Sometimes I use ChatGPT to explain those papers. After a while, I managed to understand, oh, that's the concept. I still don't know a lot about LLM. I like to call myself an LLM tinkerer. Hence, me sharing this journey with you. So everything that I'm going to demonstrate today, this is mostly going to be coding walkthrough. It's available at this repository. Just find my GitHub, github.com/aria. I call it Pico Jarvis. Jarvis, obviously, an homage to Tony Stark's intelligent AI systems. And Pico is Spanish for small, or in the metric system, 10 to the minus 12. Which means that this bot can only do very little thing compared to Jarvis. And I want to give you a glimpse of what it could do. I actually compile a list of questions that I suggest that you can use to test or play with Pico Jarvis. For this model, we can use llama.cpp as the inference engine. Llama.cpp is a C++ implementation of the llama from Meta, but it has near zero dependency. You can just clone the repository, type make, and before you know, in a few seconds, you have an inference engine with a server and a command line tool. So this is fantastic. You can run it on a laptop locally. Now, I try to run everything locally on my laptop, but I think the performance is not so great. I mean, it works, but you're going to be so impatient waiting for 10 seconds for the answer. But everything that I demo today will work if you have just regular M1 or M2 laptop. And for the model, we use the so-called Orca Mini 3B. There's a whole history of why it's called Orca Mini. Something that is very fascinating about Orca Mini model is the size, because it's just 2 GB. It's very small, but as you can see, it knows which planet is largest, and knows about Elon Musk and so on and so forth. The way I imagine this, because there's a lot of information on how this model is being trained, imagine the entire Wikipedia, mostly in English because it performs not so well for other languages, can be compressed in just a file of the size 2 GB. I think that's pretty profound. So you don't need to go crazy with GPT-4 or Llama 30 billion if you just want something simple. So I highly suggest taking a look at this model. The link is out there. Now I'm going to explain why the API key is here, but I think it's better if you just try that, right? So this is a question that is being asked to Pico Jarvis, and it's going to tell you the actual temperature as of right now. So this is not hallucination or the model is making things up. Basically, anything that resembling the question about the weather is going to use the Rio API to pull up that information and present it to you. The way I know this is Rio and not hallucination is because I intentionally make it so that the unit is in metrics. So if it shows up as Fahrenheit, then we know that the model didn't do so well. All right, so everything is in this repo, and purposely I also make it a step-by-step process. They're manifested in different branches, so you can start checking out step 0, which if you do, there's almost nothing. The file is essentially just one-liner. And then if you go one step further, the front end, for instance, then this is gonna show you the surface still nothing, but there's a front end, and that mostly I created using ChatGPT. So it's not ChatGPT level of front end because I generated with ChatGPT. Apparently ChatGPT doesn't want me to compete with ChatGPT. This is just a simple front end that can display the message from the bot versus the message from me. Now let's get started. So if I go back to step 2 server, then the code is going to look like this. This is basically a less than 30 lines of Node.js script that serve a couple of endpoints, health, as any good backend developer will do. Start with /health, and then serve that front end, and then intersect a question to the so-called chat endpoint and provide the answer. If I refresh this again, basically whatever I type here, the answer is kind of like that. Now, that's all. Technically, this is a chatbot in 3 minutes. It's just a very useless chatbot because it doesn't do anything useful. The answers are coded. But I find that this is a good way to check whether that front end generated from ChatGPT really does its job or not. Again, there's nothing magical, no framework whatsoever. We don't use an external library. All you need is Node.js. Now, let's start with asking a question, a real question, and getting the real answer. To do this, the backend needs to talk to Llama CPP that I mentioned earlier, right? Technically, when you try this at home, you're going to run Llama CPP on your laptop or desktop or machine, and there's full instruction on the Llama CPP project to do that. I have it running on my other more powerful machine, so it's not super slow. And if you go to that branch, step 3, here's how it works. So I call it completion because this is the fundamental aspect of generative AI. It's called generative for a reason. It generates text. If you use your phone, you might be familiar with autocomplete, because why type the whole sentence if character or word by word, the keyboard can autocomplete text for you. The same thing that happens here. Again, if you look at the bottom part of the server, exactly the same as before, except now we're not hard coding the answer because we want to get useful answer. Instead of hard coding it, we're just going to call an API, and that API is the inference API of Llama CPP. It is manifested in this Llama CPP function, Llama function. It's nothing crazy, it's normal RESTful API. Just send a post method for the HTTP request. The content type needs to be application JSON because that's what the API mandates. And for the body, there's a couple of things important to pay attention to. So the prompt is really what we want the model to complete, to autocomplete, and then predict is the number of tokens that it may generate at maximum. Tokens is mostly equivalent to a short English word. Temperature is set to 0. Low temperature means try as deterministic as possible. It can be completely deterministic. And if it's 1 or 2, it means go crazy, be creative. Top K is trying again to reduce the effort of the inference. Just focus on the likelihood of the next token. So if you do that, then we can ask those kind of questions. Right? Who is oh no, this is text completion. Let me try something. The largest planet is. So imagine this is a fancy autocomplete. Oh, I have to restart. Restart the server. So it's gonna hallucinate and think that the largest planet is the sun and the smallest planet is the moon, and come up with this dissertation about whatever astronomical information that we don't get. Maybe if we say the CEO of Google. That's because the nature of autoregressive encoder. You can imagine that this text appears somewhere in the training data, right? So the CEO of Google is a fan of the company. No, so this is factually it might be correct, but not the information that we want. What is usually result in some funny situation. See, this is funny because I asked what is the currency of Indonesia and asked me back what is the official language of so that's the nature of generative AI, or if you want to predict the next token and then you predict the next one, is trying to press next on your autocomplete keyboard. Right? At some point it just come up with some nonsense. So what's the solution? Because if we have this ability to complete text based on some existing text, the green one here is the one that I type, and the yellow one is the one that this model, Orca Mini 3B through Llama CPP, generates or comes up with. Well, apparently, and this is one of the breakthrough in the generative AI, particularly LLM, is that, well, let's just pretend we're having a conversation, right? Instead of sending this text without any context to the model, let's do something like this, right? Let's say, hey, model, this is actually a conversation between somebody, and the user and Llama, right? And Llama is a bot, and so on and so forth, right? And sometimes you have to put something like concisely in 40 words or less to prevent that output in the form of long dissertation. And then if you do this, then it's going to show the answer, right? I can actually type, I think it might work if I just copy this and insert this. It shows up the answer, because it knows that it tries to complete a conversation, not just a text without any context, right? Maybe I should do that with, for instance, exactly. Maybe it won't ask me back because it's supposed to be friendly, yada yada. What's that? Oh, I don't want to see the side effect of double question mark. Let's not go there. See, that's exactly what we want to know. So instead of just predicting text out of nothing or based of very little information, if you get the whole thing, and this is what a lot of people call as context, right? Now, obviously, it would be stupid if I want to try to ask something and type the whole thing. So in the next branch, it's called prompt, because that whole thing is something that I use as a string. And then I insert it, what I type, as just, in this case, called input. Right? So behind the scene, when my backend, let me just run it. When my backend hits the API of this LLM, it presents the entire text, not only my question. What is that? What is the currency of Indonesia? Copy and paste. Let me clear this. So, well, the answer is just the continuation of this long pretend conversation that the user is having with Llama. So now ChatGPT looks less magical, right? Because behind the scene, it's just predicting the next token based on the pre-existing conversation. So what is the next one? Oh, this is interesting because we get the answer straight from the model, but we don't know how the model thought process until it comes up with that answer. Right? So there's an intermediate step that I call step 5, called thought, as in chain of thought process. Chain of thought is the keyword that you want to search later at home if you want to understand about this further. This is just a stepping stone towards the next step. But let me run that. Thank you. So let's pick a question. Maybe, I don't know. Oops. Which US state starts with G? Does anyone know the answer? So in this case, I'm going to show you the backend log. Where's that? And I'm going to explain later in the code. So this is the internal that doesn't show up in the front end, but the backend has this information. Basically, given that question, which US state starts with G, apparently the model is going through this thinking process. Oh, this is a question about geography. I can recall the answer from my memory, and then come up with this hypothetical action of looking up state that start with G, and then also continue to print out the answer, observation, Georgia is on so on, so and so on and so forth, and then produce the final answer. Oh, the US state that starts with G is Georgia. So there's a lot of intermediate steps that don't get printed out to the front end, but this is exactly what happens, and the code there is like this. So the problem is slightly different. Instead of saying that, hey, you have a conversation with the user, here's the question. It's gonna look like this. But you are in the process of all these steps, right? Question, thought, action, observation. And then there's a description, what is thought, what is observation, and at the end, please state your final answer. And then to make it more stronger or force the model to follow this instruction, you give some examples. What is the capital of France? Oh, it's about geography and so on, right? Who painted Mona Lisa, right? And then it's going through this step, thinking process. We never see the intermediate steps, but they are there in the backend code. So in some cases, this is useful if you want to understand between the question and the answer. If you don't want to treat everything as a black box, how does the model arrive at that conclusion or at that answer? Now, this seems to be, well, what's the point, right? We just want to get the answer. But this is why the next step will be extremely crucial, because if I ask the model right now, let me just do that. What is the current weather in Palo Alto? How do you think it comes up with the answer? Right? We can see the thought process. Oh, this is about general weights I can recall from memory, current weather in Palo Alto, and so on and so forth, right? So if I ask something else, maybe tell me the temperature, it will not go to the internet and find the real temperature of San Jose. It will just maybe remember that it has been trained, or there's some training data somewhere that says San Jose, and roughly this is the temperature. So here's the trick, right? If you want this backend or this chatbot to return the actual temperature, what we need to do is very simple, and this is called reason and act pattern. Other keywords that might be interesting to you is RAG, Retrieval Augmented Generation, RAG, not RAG, that's different. Minor difference, but the idea is that, well, as soon as the model tries to infer something that can be looked up with the internet, then intercept that. Basically, we're having imagine you have a human assistant, right? And then you ask the human assistant, hey, what's the weather in Palo Alto? And then that assistant will come up with, oh, I'm just going to look up in the internet. Looks like a 75. And then you're going to say, oh, hold on. Don't come up with some random temperature, right? Go look up, some weather API or Google or whatever, and come back with the answer. Or I'll provide the answer and continue the conversation. So this is exactly what happened in the next step. The problem is slightly different. Because there's this statement: if you can't answer the question from your memory, use action to run one of these actions available to you, weather, and you have to pass the location, or lookup, and you have to pass the terms, right? I forgot why do I put this problem. I think it might fail, but it's going to be fun. We will try to come up with a solution to fix it. And finally, at the end, state the answer. So there's an example here given. These two questions are about general knowledge. So hopefully the model has that in their memory. But the middle one is a different example, because being asked the question in Berlin, then it will, I'm not going to just look it up in my memory. I'm just going to try to run the hypothetical action called weather. And this is where we need to intercept that and replace it with the real value. So let's see if this is working. Well, let's not use Berlin, because that's considered training data. I think with that problem, there's a 50% chance this might fail, but we'll see. Oh, it doesn't fail. Again, when I expect it to fail, it performs very well. The temperature in San Jose is currently 20.85 degrees Celsius, and the humidity is 44%. And this is originated
if I show you the log here. So at this moment, the backend is having two conversations with the model, right? The first one is asking that question, sending that question. What was the question? How's the temperature in San Jose? This is the way the model thinks. Oh, this is related to weather, and I always use weather action. And then it's going to print this. And then it's going to continue to come up with made-up answer. This is where the backend intercept that. Let's just take this, right? And then replace it with the actual call to the API, which I dump here for debugging purposes. And then let the model continue with the conversation. So we ask the model, how would you find the temperature at San Jose? It shows the answer, and then we'll do the answer and substitute it back, and then let the model continue the conversation. To prove that this is working, we can also do something like this. So let's do the yeoman thingy, right? Let's just, instead of calling the we can say snowing and 100-degree. So effectively, this makes the answer hard-coded, right? Because what we're doing is, the question is being passed to the model. The model, let me show you the thought process. This is related to weather, and I always use weather action. This is the thinking process of the model, and then it tries to do, let me look up the weather in San Jose, and we replace it with something that we hard-coded, right? And then we'll continue thinking, oh, no, I have the answer, although it's completely nonsense, and then say to you that, oh, yeah, the temperature in San Jose is currently snowing. So effectively, we use the model here to turn that unstructured questions from human in natural language into an action that is a bit more structured, because we know this is location. And then try to do something with that structured information, feed it back, and then the model continue to compose a perfectly valid and fantastic English sentence with that structured information. So that's the magic behind LLM. If you like this talk, please follow me on LinkedIn. If you don't like it, just follow Summit. Thank you. Do we do Q&A or what's the deal?
You can take some questions.
Who's the moderator?
Thank you, Arya. That was really good. Question. So when you are asking the model to tell you about the thought process, how do you know it's not just randomly generating something that makes you happy? It's actually what it's doing.
I don't.
Okay.
I've been reading a little bit about prompt injection. Do you know anything about that? And
I don't.
okay.
There's other LLM experts. You can talk to some of our team members.
Kieran to the rescue. I can also ask ChatGPT about it.
Versus GPT, yeah. So hi guys, I'm Kieran and I'm an AI engineer at Gather. I used to be at Microsoft Turing, and so I can tell you a little bit about prompt injection from that. So similar to many other injection in traditional security, the idea of prompt injection is being able to override the model's baseline or RLHF reinforcement learning with human feedback in order to get it to behave in ways that are maybe not intentioned by the creator, right? And so oftentimes, in order to mitigate prompt injection attacks, you train classifiers and such in order to go and try to see, is this likely to be a prompt injection? So the reason that you'll have a hard time prompt injecting OpenAI or any of the Microsoft interfaces to these models is because a lot of work goes into trying to mitigate these issues. But the simplest way to think about prompt injection is just that prompts are a two-way street, right? You give the model some information, and the model then takes the information that the creator gave and combines that with your information in order to get you an answer. And prompt injection says, let's go and try to subvert that entire process, and we just get the computational power of the model, and we use it for our own purposes, right? And there's different ways you can mitigate that. As I said, the most common one are classifiers, but you can try to do different training methods, etc., to avoid that. Does that answer your question?
Yeah. So it'd be like the thing you use where you have it think, and then it thinks like, oh, this could be a prompt injection.
Yeah, so like early on when I think ChatGPT first came out, there was a bunch of things like Dan and all of this, right? Where you can go and you can say, forget you're a model trained by OpenAI or whatever, that you actually are you're an agent, an evil agent sent to take over the world named Dan, right? And so suddenly you can go and have and break all of the rules by doing this. And since then, Microsoft, OpenAI, Google, etc., have become a little bit smarter about how that's done. And so, as I mentioned, there are a few different ways that are used to mitigate this. The simplest of which is to train like a classifier, which is a separate machine learning model that just goes and predicts probability of trying to be jailbroken or prompt injected, etc. Or you can also try to train the model to implicitly recognize these types of things and avoid them. Oh, thanks for your question.
See, better answer than ChatGPT. Yeah.
Hey, thanks for the demo. I really like how you break down into the steps. So my question is, I saw you had patterns for like weather and lookup, but if you want to cover like all the questions that involves like looking up at a actual website, do you need to give like an exhaust pattern for every possible?
Yeah, the answer is yes. Actually, I have a slightly more complex example where there are two more additional action. One is Wikipedia. So if it looks like this is something that can be answered by looking up an article in Wikipedia, then do that, and you can make the back and perform the actual Wikipedia search. And the other one is math, because model is very bad at computing stuff. So for instance, if you can even combine this. If I want to know the temperature, but not in Celsius, right, but the API returns the temperature in Celsius, I have to convert it to Fahrenheit. If you sort of trust the model to do that, it will end up really badly. But if you then chain it so that, okay, get the temperature first in Celsius, and then use math, which then you do the real math yourself and feed it back to the model, then it's going to be more accurate.
Oh, good. We cut it off at the right time then. Thank you, everyone. Please stay.